Good afternoon, everyone, and welcome to our break-free Lunch and Learn webinar series. For anyone new to Wavelogix, let's give you a little bit of background info. Founded in 2021, Wavelogix partnered with the Indiana Department of Transportation and Purdue University to enhance road and bridge reliability while minimizing traffic disruptions. Our patented Rebel concrete strength sensing system offers real-time, in-place concrete measurements, streamlining project schedules and reducing costs. Today, our speaker, Joe Torek, is a seasoned engineer with a BSEE from Notre Dame and an MBA from Northwestern. He holds 5 patents in microwave telecommunications technology and is a registered professional engineer. And now Joe is going to take it from here and introduce you to how to save money with Rebel.
Thanks for that wonderful introduction, Emily. Appreciate it. Welcome, everybody, to our webinar series on Wavelogix sensor technology. Today, we're going to talk about how we save money with our sensor tech. Time is money. We all have heard that before. How do we save money and time with the Rebel sensor system? First off, it allows you to do faster operations. So contractors can optimize their process flow. Process flow is very important in terms of reducing things, increasing productivity and efficiency, reducing labor waste, lowering the labor cost as it is, and enhancing your production schedules. With scheduling ease, you can get more done in a shorter period of time, and all of those things mean that we are saving money. Why is knowing the concrete strength critical in curing concrete? And how does that save cost? Well, if you know your strength and you can see that in real time, you'll be able to do things like remove the forms, remove scaffolding, do post-tensioning of bridges and decks, release traffic if you're building a pavement. If you're building columns in walls, there's segmented pouring. So when you know the exact strength, you can pour the next section without the bottom collapsing. Lifting panels in tilt-up as an example. If you don't know if you've reached the critical strength, your panel could collapse when it gets lifted up into place. So knowing that is really critical. And in a lot of cases, final payment. You need to hit the specified strength at a particular time. And if you don't hit that strength, you might not get paid. Or if you can hit that strength early, and a lot of times you can get payment early, which is always nice. How are we measuring strength today? Basically, there's 2 ways of doing it. Cylinder breaks and beam breaks are the most popular mechanism that we've been using for 100 years. Problem with that, those disadvantages are it's time consuming. It's labor intensive. It requires skilled technicians. Skilled technicians are getting harder and harder to find, and the cost is going up of labor. All those things add to the cost of the product. Cylinder breaks and beam breaks are periodic. Per the ACI types of specifications, they're done at 1 day, 3 days, 7, 14, 28 days. Today, maybe even 56 days. It's not real time. And because of that, it's more periodic, and we don't know exactly what our strength is until we do those breaks with cylinders. And there's a high potential for error. Some of the studies that have been done show as high as a 500% error in the formation of those cylinders, giving errant results. Too high, too low, all of them delay time and could cause particular problems with the structures. If we look at the cost of the cylinder breaks, typically, if you were going to have cylinder breaks done, those companion cylinders are poured somewhere between 10 and 15 cylinders, typically 15 cylinders, 5 different cylinder breaks, 3 cylinders to do an average at each one of the periodic break cycles. And those cylinders are done approximately every 100 cubic yards, or about 150 pounds of concrete. Labor costs, usually there's a minimum of about 4 hours of labor, so that's about $400 at labor today, about $100 an hour. There's transportation getting to and from the site, carrying the cylinders back. That usually adds about $100 to the overall cost. Every cylinder is usually charged about $25, so let's add in another $375. Lab equipment is usually charged at the test lab, about $100 for that. And then final reporting, profit and overhead adds about another $400. So in general, you can see that that cost for making cylinders or doing a cylinder break with a test house or even internally would probably cost about close to $1,400. If we compare that to the Rebel sensor system, our system is very easy to deploy, take about under an hour of time. So let's add in $100 labor. The sensor cost in one off is about $400. And your overhead and profit would be about $200 in there. So our total cost for deploying one sensor for an equivalent of the cylinder brakes, the 15 cylinders, would cost about $700. And that's about a 50% savings compared to cylinder brakes. On top of that, you'll end up with real-time access to the strength results of time versus strength. And we can show those results in our system, both in compression, flexural, and modulus. So you're getting real data at a lower cost. What are our advantages then of our sensor system? If you look at traditional cylinder brakes, they're tested periodically, as we mentioned, 1, 3, 7, 14, 28 days. If there's a delay, it could cause a delay if you didn't hit the target strength. So let's say you want to do your next operation when you hit 2,000 PSI. You do your cylinder brake on day 1 and you're at 1,500 PSI. Now you have to wait to day 3 to see if you hit 2,000 PSI, and you may have hit that 2,000 PSI a couple hours after you did your brake on day 1. So you might have to wait a whole nother 2 days to get there. Same thing that happens if you didn't reach your strength at 3 days, you'd have to wait all the way to 7 days. So those days missed are great opportunities for adding cost into the operation. On the Rebel sensor system, we're tracking strength in real time. You see it. You can set alerts in our system to tell you when you want to get to 1,500, you can set an alert. Maybe you want to get to 3,500, you can set an alert. So it's a much more efficient system that tells you in real time. And what does that mean in terms of efficiency? You're going to be eliminating the waiting time, and you could be saving a day or more in time. Large scale projects, if you're doing a vertical building, say a 30-story building, and you could save a day, that adds up to a month over the life of that project. And that means that absolutely lowering your cost in the production, and possibly a lot of projects, large scale projects, have completion bonuses. If you can complete the project early, you can increase and get a bonus. So saving time always means a lot to every type of contractor on a project. Let's just look at different sectors that our sensors can be used in. If we look at horizontal we classify as bridges, pavement, patching work on anything that's kind of horizontal road type of work. You can accelerate traffic or accelerate releasing traffic. That's a big key point in the horizontal world. Getting traffic moving is always a stumbling block. You can completely eliminate cylinder brakes altogether, and you can enable early payment. A lot of projects in the paving world will pay you when you reach the strength. And if you can show you've reached strength early, you can get paid early. Compare that to vertical building structures, buildings, anything that's vertical that's not pavement, really comes down to time and money again. You can save 50% in the cost of the project, and you can improve the efficiency of it by reducing time, sometimes as much as 50%. Slab work, warehouses, doing the slab, very focused on flexural strength. Our system is flexural and compressive strength. And we also throw a thermocouple in the sensor so you can watch the temperature as it rises and falls. That's very critical when you're trying to get a very flat slab. So good possibilities there. Tilt up again, we already talked about that. Ensuring safe, confident lifting without it causing a safety issue or timing. If you can lift your panels a couple days earlier, knowing the exact strength, that definitely increases the efficiency. Geotech houses, those testing houses can start to eliminate cylinders and give better information to the customer base and boost their profits. They can save more money, make more money by doing that. Ready mix. Ready mix companies, every time I talk to a ready mix company, they always are concerned about being the guy that holds all the liability. If they make a perfect mix and it goes to the job site and the contractor does something wrong, fingers are always pointed back at the ready mix company. So if ready mix companies use our sensors, they have a way to confirm their product quality and avoid costly replacements that might ensure otherwise. The precast industry, always looking for the when they can remove their forms. Time is money in the precast world. Removing forms, removing that structure, getting the next cast in place is very important. But then once the product is cast, it sits in the yard usually for 28 days until they hit final strength. But if they knew that they hit final strength early, they can start clearing out their yards and shipping product sooner to their customers, which is always a plus, making more room for more product that they can build. Internationally, I think there's great opportunities to introduce new technologies that were developed here in the United States throughout the world. Concrete is the #1 product being used today in the world, and certainly this technology lends itself to access around the world. Our product works internationally. The cellular radio that we have in the product is a global radio. So how does our system really work? It's very straightforward. We use piezo technology to create a wave that we push into the concrete as it's curing. We look at that wave and we measure the impedance of the wave. What's interesting is in any structure, when the wave hits the resonant frequency of the structure, that wave will explode. And if you look at the video on the left, you can see that wave when it hits about 60,000 psi, or excuse me, 60,000 hertz, you see that wave just expand. The resistance is the lowest at that point. And if you look at the graph on the right, the graphical representation of that, you can see that we are peaking out at around 60,000 hertz. That peak is the resonant frequency. What's so interesting about the resonant frequency in concrete is that the resonant frequency is proportional to the modulus. And the modulus is proportional to the compressive and flexural strength of that structure. So by using the waveform, measuring its impedance, and looking for that resonant frequency, we have a clear non-destructive method to actually get to the compressive strength of the concrete. And if we look at that wave as the concrete cures over time, you can see that as the concrete is getting stiffer, the resonant frequency continues to shift to the right, and you can see the representative PSI of that frequency shift to the right. And that's exactly what we're looking at in our sensor, is a shift of resonant frequency as the concrete gets harder, and that we have a way of relating that then to the strength of the concrete. Very, very straightforward technology. Very easy setup of our sensors. Drop the sensor on the ground, strap it to rebar, and pour the concrete, and away you go. Sensor starts recording it and giving you real time. System itself is pretty straightforward. It is a combination of a sensor and a data logger that energizes the sensor and sends the information to the web. The sensor has a piezo wave generator implicit in the sensor and a temperature probe, so we can measure temperature at the same time that we're measuring strength. And the sensor is a one-time use. It is buried in concrete, as you saw in the previous slide. but the data logger is outside of the structure. The sensor plugs into the data logger. The data logger has an impedance meter inside of it, a GPS chip for location of where the sensor is, a cellular radio that works on all frequencies worldwide, lithium-ion battery that has a 28-day capacity. It's wireless recharging and a cradle charger. No plugging in. The housing is completely sealed. It can work underwater, and it's a very durable housing. It can withstand environmental pressures, dropping it, getting run over by a truck. It's a very, very durable product. The system is deployed by putting the sensors into concrete and then plugging them into the data logger. Once the data logger is plugged into the sensor, it immediately starts transmitting data every 15 minutes to our cloud-based servers. We use a machine learning algorithm to take that data and convert it into the strength and show that then on a front-end dashboard where you see strength grow over time and temperature at the same time, and present it to an easy user interface. If you have internet connection, you can view the data on your cell phone, on a tablet, at your desktop. What we show on the dashboard in the user interface is very straightforward. You have the graph of strength over time, and we can present that strength in compressive strength, in flexural strength, or in modulus. And then the temperature, we show the temperature in the structure, which is the red line, at the sensor, and then the temperature at the data logger, which is the ambient temperature external. So you get a good comparison of what's going on. Temperature is as important as strength in curing because you want to know what's happening with hydration, what environmental temperatures outside the structure, how they're affecting the actual structure in itself. And there you have it with our system. The solution is an embedded sensor for real-time strength. We use a machine learning algorithm to give you a good strength estimation as the concrete is curing. We do have an AASHTO certification, which was released in the end of July of this year. It's the AASHTO 412-24 certification. So we are a certified product. Benefits again, very reliable real-time data. We can accelerate construction schedules. We can reduce construction labor cost. There's a potential for reducing cement usage by 20% in this industry. We have kind of a rule of thumb that we over cement by 20 to 25% to guarantee that we get to specified strength. By using our sensors and looking in real time, we believe that over time, contractors can start to reduce the amount of cement that they're using reliably. We believe we can eliminate cylinder breaks completely, and we think we have a great opportunity by doing that to reduce the carbon footprint of the concrete. So with that said, if you'd like more information, go ahead and scan that QR code, and I will open it up for questions.
Thank you so much, Joe. Okay, we do have a couple questions here coming in. The first one, can you explain how the Rebel system directly impacts project timelines for both small and large scale concrete projects?
Yeah, as I kind of mentioned, we believe that by knowing the real-time strength, you'll be able to schedule your work the next step sooner. Now, one of the interesting aspects of using our machine learning algorithm is that after a day, we can start predicting what the actual strength is going to be over time, all the way up to 28 days. And that means that contractors actually have a window into, oh, I think I'm going to hit the strength at this particular day. I'm going to schedule my crew to do the next operation at that time. So it's a great way to optimize labor and your schedules, and thereby reducing the cost.
Great. So piggybacking on that, we just talked about how you optimize labor. How does that then reflect the overall project timeline and costs?
Yeah, certainly if a lot of ways, if you're using labor to do cylinder breaks right now, we think that there's a cost savings at that point. If you know when you're going to hit a particular strength, you don't have to have your labor sitting around waiting for that strength. So you can optimize it. So a couple ways is just increased efficiency of redeploying the labor where it's better served, I think.
Excellent. And so by reducing the need for cylinder breaks, how does that then benefit concrete contractors, maybe even outside of their timeline and their labor?
I think if you can reduce cylinder breaks, you're going to get much more accurate data. Uh, I mentioned that cylinder breaks have a propensity of not being correct. There's a lot of ways that you can damage cylinders in the making of them and then giving you lower results. So if you're underestimating your strength, it could mean in some cases that you don't get paid because you didn't hit the strength, or that you have to validate the cylinders with a core sample, and that's actually drilling into the structure with a coring device and pulling out a sample that then you crush to validate it. That's about a $3,000 test to do core sampling, and so if you can avoid all that by having good accurate data using our sensors, I think that's a great way for reducing the cost for the contractors.
And so in that scenario that you just went through, does that also kind of help achieve environmental goals, reducing kind of a lowering carbon footprint?
Yeah, that's a great question. I think there's multiple ways that we could reduce the carbon footprint. Certainly, if you're doing cylinder breaks, you're generating about 150 pounds of concrete waste just in making the cylinders. Because once you pour those cylinders and they're crushed, then you throw them out. That doesn't sound like a lot of concrete at one time, but I talked to one test house and they do um, 600,000 cylinder breaks a year. If you divide that by 10, that's 60,000, pounds, like 150 pounds on that. That is a lot of concrete. And if you look at every cylinder break group representing about 20 pounds of carbon CO2 that it's produced, you'd be saving over 1 million pounds of CO2 just by eliminating those cylinder breaks. So every little bit helps. 1 million pounds in the grand scheme of all the types of carbon we're trying to reduce is a drop in the bucket, but every little bit helps, which is important. But the over cement that I talked about in the industry, we over cement by 20 to 25%. And so certainly if people and contractors get confidence of where their mix design is in structural strength, they absolutely can start to reduce the amount of cement that's being used. That reduces their overall cost, and that cement then has a direct impact on the carbon footprint.
And the slide you had up that was the cost comparison between the traditional cylinder testing and the Rebel was super compelling. Can we just review that again at kind of at that high level? What is that cost comparison between traditional and what the Rebel offers?
Yeah, the Rebel system is pretty straightforward. As you kind of saw in the pictures, you kind of drop the sensor in place. You use one sensor to replace the 15 cylinders that you would be doing for a cylinder break test. Um, and then you plug it into the data logger and you're done. Simple as that. And you're getting data immediately as soon as the concrete is poured over the sensor. Compare that to someone who has to, a laborer, skilled laborer who has to now take um, a wheelbarrow full of concrete as it comes out of the cement truck, take that and fill up 15 cylinders. You fill them up halfway, then you pound it 20 times, and then you hit the cylinder with a hammer. Then you fill it up again, and you repeat that. And you do that 15 times, and then you protect those cylinders on the side for a day. And then the next day you move those cylinders to the lab, and then you put those cylinders in the lab in a controlled bath, and then you take 3 cylinders out, 2 or 3 cylinders out in one day, then 3 days, then 7 days, 14 and 28 days, and you crush them in the machine. You've got the labor associated with that. You've got the equipment usage. You've got all the hauling. There's a lot of work associated with that. So just describing this process of doing the cylinder breaks compared to dropping a sensor on the ground, pouring concrete on and plugging in a data logger, you gotta see how that saves you time, labor, money, and just potential errors.
Definitely. Now, for anyone considering the Rebel system after hearing all of this, what are their first steps to take to integrating it into workflows, and what does support does Wavelogix offer after implementing?
Yeah, if you're interested in the system, the first thing to do is contact us. You can either scan the information here, contact us at sales@wavelogix.tech, and then we'll have our sales team get in contact with you immediately. We can walk through and make a presentation again to you, full details. We'll send you a quote. We'll send you the standard literature we have. And then from there, we have product in stock. We can ship within 24 hours. We have multiple ways to get product in your hands, and you could be testing in a matter of days.
Excellent. Thank you, Joe, so much for your time, and thank you everyone for joining us today. Hopefully you gleaned a little bit of information and are ready to learn more, or to even try it for yourself. If you have any questions, again, scan that code that's still on the screen. Let us know how we can help. If you have any questions that are topics for next time, and we will see you in a few weeks.